Have you ever stopped to think about how you're watching this right now? I mean, really think about it. How a video from a server maybe thousands of miles away gets to your screen on a device made by a totally different company over a network built by someone else entirely. Well, it's not magic. It's an invisible, brilliant set of rules. And today, we're going to pull back the curtain on the operating manual for the entire internet. Isaac Asimov just hits the nail on the head here. Computers, they don't do nuance. They don't guess. For them to talk to each other from one side of the planet to the other, they need a perfectly honest, totally rigid set of rules. The instructions have to be universal, because otherwise you just have digital chaos. And that really is the billion-dollar question, isn't it? How does your Apple computer know what a Microsoft server is saying? How does your Samsung phone connect to a network that was built by Cisco? The secret is they're all playing from the same rulebook. It's like a universal translator for all things digital. And that rulebook has a name, the OSI reference model. Now, I know that sounds super technical, but stick with me. Just think of it like a 7-story building. Each floor has a very specific job to do to get a message from the very top floor all the way down to the mailroom in the basement. And the two magic words here are standard and layers. This model breaks down the absolutely gigantic task of sending data across the world into 7 smaller, much more manageable jobs. And this is genius because it means a company can focus on making one thing better, like a faster Wi-Fi card, without having to reinvent, the entire internet. Okay, so here they are, the magnificent 7 layers. Now, if you want a simple way to remember them from top to bottom, just think of the phrase, all people seem to need data processing. As your message travels down the stack, from application to physical, each layer kind of wraps it in a new set of instructions. It's like a set of Russian nesting dolls. To make this all feel a bit more real, let's follow something simple, like an email. You just typed it up, you hit send, and that one little click kicks off this incredible, lightning-fast journey down all 7 layers. And what's wild is that this all happens before the message even thinks about leaving your computer. So first things first, we're at the top 3 layers, what some people call the software layers. This is where your computer's brain, its operating system, and the apps you're using does all the prep work. Let's stick with a simple analogy of mailing a letter. These first 3 layers are everything that happens right at your desk. It's you writing the letter, maybe making sure it's in a language your friend can actually read, and then deciding, okay, I'm ready to send this. So at the very top, layer 7, application, that's just the app you're actually touching, like your Gmail or Outlook. Simple enough. Right below that, layer 6, presentation, acts like a translator. It makes sure the data is in the right format, and this is also where stuff like encryption happens to keep it secure. And then layer 5, the session layer, is like the dialogue manager. It opens up the communication line and keeps it open, kind of like picking up the phone and hearing that dial tone. Okay, so our message is written, it's formatted, now we have to actually address the envelope and figure out the best way to get it there. This is where we get into the real logistics of the journey. Back to our post office analogy. This is the part where you take your letter, put it in an envelope, and write the address on the front. And if your letter is super long, the post office might even decide to break it into smaller packets to make it easier to handle. This is also where the master plan for its route gets decided. Now, these 2 layers are the ultimate logistics team. Layer 4, transport, is incredible. It takes your big email and chops it into smaller pieces called segments. This is so important for reliability, because if one little piece gets lost along the way, you only have to resend that one piece, not the whole thing. Then, layer 3, the network layer, slaps the IP address on each of those pieces. That's basically the zip code for the internet, and it acts like a GPS, figuring out the absolute best path for each piece to take across the internet. We are so close. We're at the finish line for the sending part of the process. The email is packaged, it's addressed, it has its route all planned out, but now we have to turn all those digital ones and zeros into something that can actually travel through the real world. So this is the final piece of our mail analogy. This is the actual mail truck, the driver who knows all the local streets, and of course the physical roads that the truck is going to drive on. This is where the rubber meets the road, literally. And this is where the magic really happens. Layer 2, the data link layer, handles the very last step of local delivery, like getting the data from your computer to your Wi-Fi router just a few feet away. And then layer 1, the physical layer, this is what blows my mind. It takes all that organized data and turns it into a physical signal. An actual electrical pulse in a copper cable, a radio wave for Wi-Fi, or a tiny flash of light in a fiber optic line.
And just like that, poof, your email is on its way. It's left your computer. Now, once it gets to your friend's computer, this entire 7-layer process just happens in reverse. It comes in as a physical signal at layer 1, it gets reassembled, it gets routed all the way back up the stack until it pops up, fully formed, in their email inbox. Incredible.
So, okay, we've got this whole 7-layer cake of rules. But why? Why go through all this trouble? Why is having this model so fundamentally important? Well, it all boils down to 3 huge benefits. First, interoperability. This is the whole reason your Apple iPhone can talk to a Google server on a network that's run by Verizon. Second, standardization. It creates that common rulebook so innovators can build cool new apps or faster hardware without breaking the whole system. And third, and this is a big one, troubleshooting. For any network technician, this model is a lifesaver. If your internet's down, you can check layer by layer. Is the cable unplugged? That's a layer 1 problem. Can't get an IP address? That's a layer 3 problem. It turns a huge, scary problem into a simple checklist. At the end of the day, this model is really a chain, isn't it? Every single layer depends completely on the ones above and below it. It makes everything we do online possible. But it also shows you just how delicate that balance is. A single broken link, one little error in just one of these layers, and the whole conversation just falls apart.